All right. Looks like we can get started. Apologies for the delay. Getting things going. Still kind of in holiday mode a little bit. So had to get my bearings. I'm like, how do I do this again? I don't do it for a week and I forget, evidently. That's what happens. So, yeah. Anyways, let's just jump into it. Get my environment up and running. Do feel free to post any questions you have regarding any Python questions you have regarding the material, or it doesn't have to be within the scope of the Galvanize, or it doesn't have to be from the Galvanize premium prep material. It can be from wherever, from another site like Code Wars or HackerRank or whatever. Just so long as it's within the scope of what we're talking about, then I'm happy to take it on stream. Let me pull this up so we can actually. Okay. Let's see here. Apologies. Let me start a thread here. Oh my gosh. My computer is acting so slow. Cool. Okay. Cool. Looks like we do have a question. The question is, can I go over importing and the difference between random.random, random.choice, and random.randint, for example? Also having difficulty hearing. Oh, okay. Looks like my volume may be a little low. I'm gonna raise up my gain on my microphone here, so I'm gonna try not to blast your ears. Okay, that should be good. Maybe getting a little bit of a peak there, but yeah, actually we are getting a little bit of a peak. All right, how test testing. Dang it, moved it too much. So sensitive. Do minus 4.8. Check. Okay. Check. That should do. Okay, good. Thanks for letting me know. I recently got some new headphones, and hopefully these will be more consistent for streaming, but I'm still getting used to them. So, yeah, thanks for letting me know. Okay, so let's go over this question. I'm just pasting in my text editor here, and we'll go over it. The question is, importing and by example, a random choice and random randint. Okay. So I'm just going to cover it in terms of how I'm understanding this question. So I'm just going to cover this question in very generic terms. I'm not exactly sure where you're at to the question asker, but we'll just kind of take it from the top with this and go step by step. And hopefully we'll cover any curiosities you have, as well as anybody else wondering about importing. So importing allows us to utilize code from other files that are like other libraries that are built in to Python, interfaces to other libraries and things that are built into Python, importing also allows us to pull in interfaces from third-party libraries that we would have to install, or our own code, right? So I can write I can write my own library as well. And let's kind of look at that a little bit here. Let's see. Let's see. I'm in. So I have. I'm in my little Python sort of experimentation directory, and I have these, just a few random files in here. So let's just look at main.py. So some of you might notice, like when I'm working, when I'm in my little environment here. Let's see if this is actually gonna have a little trouble with my terminal. Sorry. So when I'm working, you'll see my code run kind of automatically down in here in this terminal. What's happening, what I'm doing, is I'm executing a file watcher. This says watch the whole directory for changes. If any file changes, then execute this command. The command to execute every time a file changes in this directory is ipython3 main.py. So I'm just showing you this to show you what's in main.py and why it's important in this case. So let's open main.py. So I'll say atom main.py. Let's take a look at it. So this is all that's in main.py right now. And what I have here is, and I just have these other two commented out because I'm not using them at the moment, and I'm importing the file that I'm actually using, right? So this is called test.py. If this was called noodles.py, I would say import noodles, and that would bring in the Python file in the same directory as main.py, as this file called noodles.py. I don't have to put the .py after it or whatever. Import is concerned with like bringing in Python code, so it knows that I mean a .py file, right? But in this case, it's not called noodles.py, it's called test.py. So in order to import this file, which is essentially a library, into my main.py, I can just say import test, and it knows to go find that. So this is a little backdoor into how importing can be useful. It can help you connect your files together. And obviously, we can import tools that are built into Python but not included by default, right? So this question also, we're wondering about specifically the random library. So let's look at that. So random is not a library that I wrote, obviously. It's built into Python, but it's not included by default unless we ask it to be included by importing it. So if I try, for example, to show how it's not included, if I try to say random dot random, let's just print that out. Whoops. Random. Switch over to where this is actually running here. Is it running? Okay. So this is going to say random is not defined. And it's kind of confusing because it's random.random. So which one does it mean? Maybe it means both. Let's do random.choice. I'll give it a list of things to choose from. So this will be hopefully a little clearer. This will also give us the same error. It says name random is not defined. So it's not even concerned with choice. It just doesn't know what I mean by random. Now, according to the terms of this question, and as many of you may know, and I think we mentioned this in our material too, obviously random.choice is a function that's built into Python, but we need to include the library called random to bring in the tools associated with it. So what I recommend doing is just a simple import. We can just say import random. And so now I've brought random into the scope of my program. My program will be aware of random. In this case, you remember I had import test. And the reason it knew how to find test is it was in the same directory here, right? If we look in this, let's just look in this at the files in this directory. I don't have a file called random, and I don't need to. In this case, Python knows what I mean by random. This is one of its built-in standard tools. It's in what we call the standard library. And we're just bringing it into scope from the standard library. So I don't need to have random in my directory. I don't need to give it a path to random. I can just have it tell it random, and it knows to go grab that specific library from Python. So, okay. All right, so you can see we import random, we run the same code, and now it's going to work. Now random.choice is going to choose one of the things that I gave it. So this time it chose 4 randomly. This time it chose 4 again. It's probably just going to choose 4 forever just to like show me up. Okay, good. It chose 3. So you can see that this code is working like we expect it to. So since this is requested, let's just look at each of these three particular methods from the random library. And we'll go from there. So random.choice, random. Okay, so let's look at random.choice first, since that's what I have. So choice. So of these three, I tend to use random.choice, like kind of by default. Just if I need a randomness tool, it's sort of what I go for. Reason I like it is you can pass it a list or a string or a tuple, and you get like specific control over what things it's going to give back randomly. It's just going to give you one of those elements from the collection that or the sequence that you pass it randomly. So yeah, I don't know. It's sort of what I go to unless I have some reason to use one of the other ones, but it's sort of my easy default, I guess. So I know how this particular method or this particular function works because I use it all the time. But let's say you're new to the random library, which presumably many of you are, and you want to know how to use different things. Let's say the first question is what tools are available to use. So we can actually do the dir function. We can print the directory of the random library. So we can say print dir random. And I'm not going to do random.choice. I'm just going to say random. So that's naming the whole library. And dir is just going to give me a list of all the methods that exist in the random library, or all the functions. Okay. So you can see we have a bunch of kind of special like constants and methods and things. The capitals are, I believe they're constants if it's following the convention that I think it's following. And then we have these under and dunder methods. I'm going to say ignore these for now and just look at the regular named methods, which are going to be at the end, right? We don't have to like necessarily understand all these, but this is what I do when I'm using a new object that I'm not familiar with or a new library that I'm not familiar with. I'm going to print out the directory to kind of just start to explore it, right? This obviously doesn't go into immense depth about any of these. It just kind of gives me an at a glance what's in that library, right? So we've got beta variate, we've got choices, expo variate, excuse me, gamma variate, Gauss, get rand bits, get state, right? So you can kind of look through this and just kind of get an idea of what tools you'll have available to you. Some of these, I mean, honestly, I don't know like what expo variate, gamma variate. I don't know what these are, but presumably they're components of the mechanism that Python is implementing to achieve the randomness in general. So you can kind of manipulate the random generation this way. I've never dove that deep into this, although it seems actually really fun, and I probably should do that because it would be awesome. But I haven't done that yet. You can do that if you want. But yeah, you can see that there's a few things that seem familiar and a few things that in here that seem kind of obvious as to what they do. Well, I just kind of hosed it. Okay, well, hit something that pasted all that in by accident. So you can see we have choices, randant, random, sample, seed, shuffle, right? So there's a few in here that seem kind of obvious and maybe a little friendlier that would pique my interest. So I could say, okay, let's look at choice. Choice seems like maybe it's going to choose some random element. So what I can do here is I can say random, or excuse me, help. I'll use the help function, and this will say help random dot choice. Now, notice I don't put the parentheses after choice. I just want to give the name of the property that I'm interested in, and let's run this. And then this is just going to access the internal documentation for choice. So it's going to say help on method choice in module random, tells me where it is. Obviously, I know where it is, but yeah. And this will say choice takes in a sequence. It's a method of the random.random instance. And it chooses a random element from a non-empty sequence. So if you read a lot of help documentation, you kind of get a feel for how it's laid out. But I know that this syntax here, where it says choice sec, tells me that it takes an argument that it calls sec, seq. And I see sequence over here, so seq is short for sequence. So choice takes in a sequence, and it chooses a random element from that sequence and returns it. So if we just tried that out, you might think, well, what kind of things would you think of as a sequence? Random dot choice. Obviously, I showed you, a list is a sequence. But you might think, well, maybe a string is a sequence. So let's just pass it a string with hello that's misspelled in here. Probably going to get an L because there's a lot of them. Nope, we got an O. Yeah. So if I run this with this string, you can see I'm going to get a different character from this string every time, right? So you might think, well, maybe a tuple is a sequence. So maybe if I say hello and goodbye. Oops. So it's going to give me goodbye this time. I'm running the help on random.choice every time. So you can see I'm hoping to make a process obvious for how you can use Python to sort of teach you Python, right? So I can use dir to kind of get an idea of what's available. You might have seen me use dir before for like list or stir or one of the built-in types like int, right? We could do the directory for an int. And since the types in Python are objects, and since the modules that we import are objects as well, like random, dir is going to work exactly the same way. Because objects play such a wide variety of roles. So then you can see the directory for integer is all this here, right? So I'm hoping to give you sort of some clues about how you can use the tools built into Python. Obviously, print, dir, there's help. So I use dir for getting an idea of what's available to me. If I see something that piques my interest, I'll call help on it. And then I'll just start trying things out. I'll just start experimenting with it, right? So yeah. Cool. Let's just do that. All right. Let's also look at random. We looked at choice. Let's look at random.random and random.randint. Okay, so random.random. Well, let's pretend like I don't know it, and we can just call help on it. Oops. So you can say random.random. Wait for it to load. Okay. Help on built-in function random. Random and then parentheses. So this is kind of showing you how it's called. Notice it doesn't specify an argument, so presumably it doesn't have one. So we can take that away. We can just call it like this, print random.random, just with parentheses and no argument. It's a method of the random.random instance, obviously. Random, and then this right-facing skinny arrow means returns. It's sort of a shorthand for return. So random returns x in the interval 0, 1. That looks like a typo, like that was intended to be a closing square bracket. Or it's a kind of notation that I'm not familiar with, which is also entirely possible. Wonder if that's a typo in the documentation though. But if we run it, we can see we'll just call random.random, and often, honestly, the documentation kind of gives you a vague idea of something. Really, what I'm looking for is for it to tell me what its arguments are and how to call it. And if I can properly invoke it, which in this case is just with parentheses and no arguments, if I can just experiment until I can properly invoke it, then I can kind of start learning about it, right? So let's just run this. So we got like 3 point, what did we get last time? 3 point, or 0.3538, we got 0.6095, whatever. So if I ran this a bunch more times, you'd see pretty quickly that random.random is going to give you a randomly generated float value between 0 and 1. It'll never be less than 0. It might be equal to 0. I think it can be equal to 0 or equal to 1. So it'll be just less than, or it'll be greater than or equal to 0, between greater than or equal to 0 and less than or equal to 1. I'm not sure exactly on that. I'm not sure if it includes one boundary and not the other, or includes both or excludes one or something. Anyways, so that's how random.random works. We could do the same thing for random.randint as well. Let's just kind of play pretend on that as well. So we'll say, I'll just copy these and uncomment, and we'll select the .random. I'm going to do Command D to highlight both, and then we'll say rand int. Okay, so let's call help first and get the help on random randint. Okay, so randint takes A and B. It's a method of random, returns a random integer in the range A, B, including both endpoints. So it's inclusive of both the lower and the upper boundary is what I'm taking away from that. So if I did random.randint 2 to 5, that should give me a random number between 2 and 5. That's going to give me 3. Well, that fits. Let's just call it a bunch of times. Let's say 4. Uh, 20. And I don't need I here. I'm just going to do underscore. So for underscore in range 20, print random randint between 2 and 5. And this will call it a bunch of times, and we'll be able to see, does it include the upper and lower bound or what, right? So 4, 2, so it does include the lower bound. 3, 4, 3, 4, 2, 2, 3, 5. It took us a while to get a 5. We got 2 5s here. So it does include the upper bound as well. And it looks like we've got 2, 3, 4, and 5. So it gives us an idea of how that's going to work. You can, some of you might be wondering this, right? Can you use, since this perhaps may feel like a range, right? It may, if you're familiar with the range function, randint might feel somewhat familiar. It's like a range that gives you a random number from that range. You might be wondering, can you use random.choice? And choice takes a sequence. You might say, is range a sequence? Let's actually just do this. So let's see what this is going to do. Call this 20 times. Maybe it'll give me an error. Maybe it won't work for some other reason. I don't know. Who knows? Well, I know, but one may not know. Okay, cool. So we got 3, 4, 2. So it looks like it's including that 2. This range is just going to give me the range. You know, it's going to obey the rules of range, right? So range includes the lower bound, but not the upper bound. Random.randint includes both the lower and the upper bound, so it's inclusive of both. But if we look through here, so we're going to get 2s and 3s and 4s, but we're not going to get any 5s because we're not including 5. So if we used choice with a range, we would have to include it if we wanted it included. But you can do this, or you can just use random randint, and that'll work fine as well. Cool. All right. We have another question here. Also, let me know, to anybody curious about this, feel free to provide any follow-up questions or things like that. Yeah, to the person asking the question, let me know if that helps or if you have any follow-ups to that. For now, I'm just going to move on. We have another question asking about if I'm going to cover probability materials. I'm not going to cover probability materials in study halls yet, perhaps in the future. I want to keep things focused on Python, mostly because that's where we want, in general, that's where we see the most need for people to have a solid foundation. So for now, I want to keep things, mostly Python oriented, because just in terms of our pipeline and the concerns of the DSI, we are noticing that it's most important for people to have very solid foundations, particularly in Python. So yeah, I'm going to keep it local to that for the time being. Apologies if that's any inconvenience, but thanks for asking. Okay, cool. Suppose I don't need to comment all this out. Leave that there, and perhaps I can slack that in later if I remember. Okay, so I don't see another question at the moment. I don't see any follow-ups to the questions on importing or on randomness, so I'm just going to assume that I explained it perfectly and that everybody has complete mastery and total comprehension. No, I'm just kidding. But yeah, I'm going to assume we're good for now. And since I don't see anything, I'm just going to continue on with the going through the material. Cool. So last time it looks like we left off here traversing a single nested list. I'm going to talk about looping through nested lists. So by the end of this lesson, we want you to be able to write nested for loops with the correct syntax. Anticipate the output of nested for loops. Okay. So for loops allow us to repeat some process, but they themselves are a process. They are part of whatever code we write, and quite often it makes sense to put a for loop inside another for loop, which is something you can do. Loops do execute in a linear fashion, meaning they execute the first thing in the loop and then they move on to the next thing and the next thing. So we can use that as a way of thinking about how loops work, but it is also literally how loops work, right? So when you have let's say a loop within a loop that's going through something 10 times for a collection that has 100 elements in it or something, you're going to run that inner loop 10 times for each element in the outer loop, which is going to be 100 times 10, which is going to be 1,000, right? So you potentially loops can have this effect of like compounding the computational complexity or the amount of time that is required to complete some process. So there are problems where nesting loops can be really helpful, and there are definitely times where you want to do this. In general, once you're nesting a loop, you want to kind of just give it a little thought, like, do I need to do this, or can I just do this in one loop? So there are definitely problems where it helps to do two, but sometimes you can optimize it and do it in one. But we're going to be looking at problems that require two. I just say that just so you don't go hog wild and start writing a ton of nested loops without knowing what you're in for, potentially. Okay, so we're talking about nested lists, and that's basically just a list of lists, right? So notice this list called nums here. Let's just copy all this in real quick. Get rid of this 2-space code. So we have this list called nums, and let's call it nums list, just to be clear about what it is. It's a list. And it has 3 elements in it, right? The way we count the elements in this list is by just counting the outermost elements, right? We don't count if the elements themselves are lists. We don't count these elements as elements of the parent list, right? So this has 1, 2, 3 elements in it. Okay. So we can say, the way I would do this, just for clarity's sake, I would say for sub list in nums list, let's just print sublist, comment that out for now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see we have these lists printed out in their respective forms, right? So for sublist in nums list, then we can also do, since we determined that each element of this list is itself a list, we can loop through that list inside the loop. We can say for num in sublist, print num. We don't need this code now. I just rewrote that same code in the example. I'm just using different names that are a little more descriptive in my opinion. So let's do this just to make it clear. We're not printing the index. Okay. It's probably clear that we're not printing the index to most of you, but just to be absolutely clear here, you know. So we've got 11, 22, 33, 44, 55, 66, 77, 88, 99. So you can see, hopefully you can see from this, that this is a way we can loop through every element in the nested lists. Okay. Let's just read through this. So for loops can be written inside of other for loops. These nested for loops will go to the first item of the list in the outer for loop I would say from the outer for loop, and iterate through every item of that inner list in the inner for loop. Then it'll go to the second item of the outer for loop and iterate through every item in that list, etc., etc. Okay. This is just a little breakdown of how that's going to work. I'll leave you to go through that. I think we can just jump in. Let's just jump in and do the challenges. And feel free to ask questions about what I'm going through here too, as well, if you may have them. All right. So what will the below code print on the last iteration of both loops? I times j. So for I in x, it's going to be the elements from this. For j in y, print I times j. So this is going to multiply every element in y by every element in x, right? So the first iteration, we're going to have x is 0, and then we're going to say print 5, or yeah, print 0 times 5, print 0 times 6, print 0 times 7, 0 times 8, 0 times 9, 0 times 10, and then it's going to move on to the next element, which will be 1 in x. And then it'll print 5 times 1, 6 times 1, 7 times 1, 8 times 1, 9 times 1, 10 times 1, etc., right? So at the very last thing it's going to print is 5 times 10, which is going to be 50, so that'll be 50. Cool. In the code below, how many print statements will print the number 4? What? presumably 1, because there's only one, so we're doing I times j again. Same sort of loop setup, there's just a little bit different loop structure, right? So the only thing that I see multiplying together to make 4 is 2 times 2. Yeah, so I presumably just one of them. I'm only going to see 4 once. Okay. Traversing a list. Did I solve this one? Is that the solution? No, it's not. Okay, good. Then in the code below, write a for loop that will add the corresponding values, list 1, list 2, and list 3 together and store them in the corresponding position called output list. Okay. So, interesting. So it looks like we have a little test here. Let's just copy all this into the environment where it's much nicer to work. And let's take this because it's kind of a test and we can use it to test everything. We'll just use it, we'll comment it out for now. Okay. So let's say, what is it called? Output list. We'll take output list, pop it in here. Output list equals a list. And we want to add each element in each column, right? So let's look at this test, and this will help us kind of determine what should be happening here. So what I'm seeing is 1 plus 2 plus 1. 1 plus 2 is 3 plus 1 is 4, and we get 4 here. 2 plus 3 is 5 plus 4 is 9. 3 plus 6 is 9 plus 5 is 14. So we just need to add the columns here. So this is funny. This is kind of a gotcha, it seems like. So for I in range, let's see, range len list 1. We'll say output list dot append we'll do this. Sub I plus each other. Okay. I think that'll do it. Let's print it out. Print output list. Let's try it with this, since that's what I'm expecting to see anyways. We'll just do that. 4914. Okay, cool. So this looks correct to me. Oops, I don't need that print. I'll just grab that, pop it in here. Okay. So this is kind of a funny one because it's not actually asking you to write a nested for loop. This is asking you to just write a for loop, but I kind of thought they were going to do something else. This is a good problem to have here, I think, because you do need to know when to nest and when not to nest. But it's kind of a little bit of a pull the rug out from under you sort of thing. But another thing we could do here is we could add them all together. And say I, J, K, and list 2, list 3, and we'll do I plus J plus K. This is going to give us a different result, but if the question was formulated differently, like add together all the numbers in every combination, right? This is gonna do that as well. This is pretty brute force, and it's only going to work for 3 nested lists, right? It's not that flexible, but it'll get the job done for this particular instance, at least. Cool. All right. Again, I'll just reiterate, if you have any questions, feel free to bring them to the table, and we can get going on them. Any Python questions, I should say. Cool. All right, the enumerate function at long last. I've had a lot of questions about this. This is where for loops kind of start to feel a little bit funky, because enumerate kind of changes your for loops a little bit. But yeah, let's look at this. So write a for loop that can keep track of both indices and items in a list. Use the enumerate function to write more complex for loops. So every time, okay, here's, I think the big question that I get with enumerate, we'll actually look at how to use it, obviously, but the big question that I get with enumerate is like, when should I use it? Okay, so you probably think of a time where this has happened. If not specifically, then generally you can probably relate to a time where this has happened, where you think, okay, I'm looping through a collection and I need the index. If you have that thought, like, I think I might need the index, just enumerate your collection that you're looping through. It's not going to do you any harm, and you're going to get the index. If you don't end up needing the index, then you can always like, change your loop head to not use enumerate. But I kind of just say, like, if you think there's any possibility that you might need the index of each element in your loop, or if not the index, like a positional, a number that just sort of marks the position or the progress through the loop, so you can kind of keep track of what loop you're on, right? And you can use enumerate. All right. So sometimes you'll need to loop through the items in a list and keep track of the index of each item. The enumerate function iterates through the item and variable counter that corresponds to each item, what I would usually call the index and the element. Okay. So I think, let's just kind of look at an example here. I think this might be one of the challenges. Let's say I have a list of numbers. Wow. and I want to raise each number to the power of its index. So I want to print num to the IDX, right? So let's do that in a for loop. Let's say for, we'll go for the enumerate version, IDX, comma num in list. Oops, enumerate. I just said enumerate. In enumerate list. Here we are on a lesson about enumerate, and I forgot to write enumerate initially. Cool. Okay. Cool. So 4 to the 0th is 1. 5 to the 1st is 5. 3 squared, 3 to the 2nd is 9. 8 to the 3rd, that's going to be 8 cubed, is 512. 6 to the 4th is 1296. 7 to the, what is that, the 5th? Yeah, is 16807. And 1 to the 6th is just 1 again. Cool. So let's just kind of throw that in F string and kind of get a better look at it even. Let's say IDX, or we'll say num to the power of IDX. So hopefully this will give you a better idea too. So 4 to the power of 0, right? The number is 4, the index is 0. And you can see the indices are going to be 0, 1, 2, 3, 4, 5, 6, right? So enumerate is, again, that's going to give us access to that index. You also have the choice to, the option on where to start the index. A lot of times you'll use an index in a solution, but you'll like add one or subtract one from it and use it in whatever way. So enumerate takes an optional second argument. The first argument is always the collection that you're enumerating. And the second argument tells it where you want the index to start. So, excuse me. Let's say I want it to start at 1, right? We'll just raise these all by 1. So you can see these indexes are going to be raised 1 through 7 instead of 0 through 6, right? Cool. All right. Okay. I reckon let's just move on then. Yeah, I totally just kind of took this for granted. If you're really new to enumerate, this might seem a little funny because it kind of changes your for loops a little bit, right? You now get to identify 2 things instead of 1, right? Instead of 4 element in list, you have 4 IDX comma element in enumerate list. This will actually work if you only do one thing, but it's going to be a little different, right? So enumerate gives back a tuple every time. So if we say for, let's just call this I, and let's just say I'll print I. Think about like what you might expect as this loads. Right, so we can see that this is actually going to give us a tuple back. 1, 4, 2, 5, 3, 3, 4, 8, 5, 6, 6, 7, 7, 1. So you can see the numbers on the left are 1, 2, 3, 4, 5, 6, 7, and I'm still starting the collection at, or the index at 1 there. But if I don't do that, I started at 0. 0, 1, 2, 3, 4, 5, 6, right? And then the elements on the left, or on the right-hand side, are going to be the elements from the list itself, right? So enumerate gives us back a tuple, and we can unbox that tuple in the for loop, which is really nice. So we can say for idx, comma num, right? And this is like saying, if you're familiar with unboxing a tuple, right? You can think about this like for I in enumerate list, idx, comma num equals I. So it just saves you from having to do that like first thing in your for loop. But this will do the same thing. That'll give you index and num. Of course, we could also do, even this is a shorthand for saying idx equals I sub 0 and num equals I sub 1, right? So that's just happening for you in the loop when you say for idx num like that. Yeah. Oh, this is worth mentioning as well. Here they're giving an example where they're starting the index at like -62. I'm not sure how useful it is to start at such like a negative, I don't know, number like this, but there might be a use case for it. You can start that index at any number, and it's going to go up, and that's the only option you have. Actually, it's just going to go up by steps of 1. You don't have as much control over that as you would like a range or something, but you still have a lot of control over it. Okay, cool. On to the challenges. What's the proper way to declare a for loop using the enumerate function on a list called list, since it can be done with or without a start parameter? Okay, so for idx and val in enumerate 1 and list. So enumerate takes either 1 or 2 arguments. The first argument, if it takes 1 argument, it's just the collection to iterate through. If you give it 2 arguments, that's going to be the collection to iterate through, followed by the starting number. So that has to be like a list and then an integer. This gives me an integer and then a list, so I know that this one's not the one. Length of the list. Len returns an integer, so passing an integer in to enumerate is going to give us an error, so I know it's not going to be that one. For the index and the value. Oh, also this one doesn't give me access to the index from the for loop. Like I said, you don't have to do 2 things there, but it's kind of really nice to. I don't know why you wouldn't. And then for idx val and range, you can pass a range as a collection to enumerate. That's totally valid. Range is a list-like object that can be treated as a collection, so you can enumerate a range. However, you can't. Range takes 1, 2, or 3 arguments, and here you can see it's being passed 1 argument. The types, whether you give it 1, 2, or 3 arguments, the types of all those arguments have to be integers. They can't be floats. They can't be strings. You could do the range of the length of the list. So you could do enumerate range len list, but that's not what's being shown here, and that's also not what's being asked for in the question. So even though this would satisfy enumerate's type requirement for its argument. Range is an appropriate type to pass to enumerate. List does not satisfy range's type requirement for its argument. So this is going to give us an error on the range function. And then, so by omission, since I know that these three are wrong, obviously I know this one's right, but let's just look at it. For the index and the value in the enumerate list, which is our first argument, and 1, and this is in the proper order because the first argument to enumerate has to be a collection to enumerate, and the second is where to start that collection, so it's got to be that one. Cool. What will the below code print on the last iteration through the loop? For index and num in enumerate my list. Okay, so the indices are going to follow from 0 through whatever the length minus 1 is. They're going to actually be the indices. So this is a list of the range 1 to 100. So this is going to be 1 to 100. So that's 99 elements. So I think that's going to be 0 through 98 over num. This is going to include 100. So 98 over 100. Is that? I think that's going to be 0.98. Ah, it's not. I actually have to run this code. I cannot do that in my head, evidently. That's fine. The answer to any programming problem is just run the run the code. It is the perennially useful solution. Let's just do this. I just want to confirm. So obviously I have the answer, which is 0.99. So the highest index is 99. Okay. And the highest value is 100. And then let's see here. 1 through 100 is not 99. That's 100. Gosh. Okay. Dyslexia, activate. Cool. So that would be 0.99. Great. All right. Okay, here's the question I was thinking about, and I kind of gave an example of this. I'm certain I've solved this. I've had a lot of people ask about it. Let's just workshop it real quick. We'll go through how I get to a solution. Okay. Write a function called alt series. Function should have one parameter, which will be a list of numbers. Function should, in variable called alt sum together all the numbers in the list where the values with even indices are added and the values with odd indices are subtracted. In a variable called powSum, it'll sum together the result of raising each value to the power of its index. And in a variable called idxSum, sum together a result of raising each index to the power of the value at that index. Okay, so these three variables. So I'm just going to pop these down here. So let's just get out what we know for sure. Function is going to be called def alt series, takes in one argument, which is a list. It's going to have these three variables in it, which are each going to be, these are sums, so I think we start them all at 0. And here we have some examples. These are just nice little packaged tests for us, so let's just pop those in. And we'll just comment that out so we have valid code. And since we want to see the results, otherwise it's not going to be very useful just calling it, we'll print them out so we can actually see. Okay, I'm running the code just to make sure it's running. And, like this is going to say, maybe I deleted something or I messed something up just if we would get an error, but we're not going to get an error. These are going to return none. That's because there's no return value here written in, so print is going to print out none since these don't do anything yet. All right, cool. So it's going to do that process, and then it's going to say the function should return these three variables in the order altsum, powsum, and index sum. So that's kind of nice because I can just say return altsum, powsum, idx sum. Yeah, nice and easy. Okay. Okay, so recall that in order to return multiple, that's just talking about how to return multiple values from a function, which is this. We can just comma separate them, and that'll return multiple values. The summation index should start at 1. Okay, cool. So I can just jump in. I'll say for idx num and enumerate list. The summation index has to start at 1. What they mean by that is that we want you to start the enumerate at 1. And then we'll say if, so let's look at altsum. So now I'm just going to go through and kind of check each of these off. So we're going to say, we'll start with altsum. What does altsum want to do? In a variable called altsum, sum together all the numbers in the list where the values with even indices. Okay, so if the index, so if idx is even, in order to tell if it's even, I'm going to say if idx mod 2 equals 0, if idx mod 2 equals 0, then we're going to say alt sum plus equals num. Else we're going to subtract it. Else not else. And then from here, so let's just run it at this point. Not like any other point would have been a bad time to run it. So this one's going to be 4, and this one's going to be 0. And we get 4 and 0 in the first place. Good. So powsum is going to be powsum plus equals num to the idx, and then this is going to be num idx to the num, and this will be idx sum. Let's see if that's going to work. So for this first one, I expect 4, 4, 3, 3, 0, and 6, 6, 2, 8, 2. And that's what I get. 4, 4, 3, 3, 0, 6, 6, 2, 8, 2. And for the second test, I expect, get on my way. I expect 0, 4, and 10. And that's what I get. I get 0, 4, and 10. So that looks like it's working. Let's see, I already have a solution here. Is this verbatim exactly? Well, I appear to have written exactly the same code twice, which isn't, I guess, that surprising. Well, I formatted this differently, but same difference. Cool. All right, run tests. Cool. Got a little bit of time left. let's see here. Okay, we're going to go on to accumulators. It's kind of the bread and butter. You think about the accumulator function, or the accumulator pattern, as like the bread and butter everything algorithm. It's like a problem-solving strategy that can solve a sort of shocking number of problems. This is an accumulator. You know, presumably most of you know what an accumulator is at this point, but yeah, I always like to kind of play up the importance of it. It's not something to overlook. Okay. So by the end of this, you'll be able to define an accumulator and understand the accumulator pattern. So an accumulator in a nutshell is we initialize an accumulator variable. The variable can be basically of any type. And what we do is we go through a collection and we run some process on each element in the collection, and we modify that accumulator variable accordingly. Quite usually we'll, like if it's a numeric type, we'll start it at 0 or 1 or something close to 0, sort of a neutral number, if there's such a thing. If it's a string or a list or a collection, quite often we'll start it with nothing in it or just a few elements in it. Sometimes you can sort of help your process by adding an element or two, whatever, to it. Sometimes that can be useful, but you're starting at a neutral starting place. So quite often you'll start with something that's 0 or empty or neutral in that manner, although it's not necessarily always the case. Its initial state is subject to whatever the constraints of the problem that you're solving are, but quite usually it's 0 or an empty collection or whatever. Then we repeat some process with a for loop or a while loop, and we modify the accumulator according to that process. There may be different conditions that tell us to do different kinds of modifications, or tell us whether or not we should or shouldn't do a modification to it or whatever. Cool. If the above loop terminates, the accumulator has the correct value, and we can go from there. All right, here's an example where we have a list of single characters, and we want to use an accumulator to iterate through this list and accumulate each character into a string. So we have 4 letters for letter in letters list. Phrase equals phrase plus letter. That'll concatenate each letter individually onto phrase. For those of you who know the join method, this obviously is just mimicking that behavior, but you use the join method, but that's just an example of a string accumulator. We would call this a string accumulator because the type of the accumulator target, the thing we're targeting for accumulation, is a string. Okay, true or false, the accumulator pattern can be applied to the following task. Given a list of numbers, find the total amount of even numbers in a list. Find? Well, find. So finding the total amount of even numbers in a list would involve counting how many of those numbers there are, right? So I would imagine this would be an integer accumulator, so I'd say true. It's actually a really good example. Like there's a lot that you do in normal day-to-day thinking in everyday life that is, algorithmically an accumulator pattern. Anytime you're counting something, that's an accumulator pattern, right? Yeah. Yeah, anytime you're going about like counting anything, you're algorithmically you're doing a accumulator pattern in your head. Okay. What will be the value of x after the accumulator code runs? X equals 0, we got a number list. For num and num list, x plus equals num squared. I don't know. It's probably obvious, but you know what? Just run it. Oh, I have to print x. By the way, copying pasting code into an environment to see what it does is an absolutely acceptable way to me of answering these questions. Programming is about automating tasks and making them easier. There's a skill in being able to look at this code and like quickly, or even at all, just being able to like come to reliable answers on how the code is going to execute. That's not really a skill that I want to teach in Premium Prep, or that I want to emphasize that you have before you start the DSI. The way that you internalize, I guess this is my opinion, frankly, but I would say the way that you should internalize an intuition of how code is going to run, what it's going to do, is just by running your code constantly. In this case, this looks like a lot of work to do in my brain. Maybe it's not. Perhaps it's much easier than I think it is going to be, but I don't really want to do all that raising to powers or squaring and multiplying and adding in my head when I can get Python to do it for me. So in the spirit of what makes programming useful, be lazy. Copy paste that, run it in your terminal, see what happens. That's what makes it useful. So this says 385, so presumably 385. All right, so complete the accumulate function below according to the docstring. All right, so returns an object that is the accumulated result of chars. The parameter is chars, which is a list of characters, returns a string. So let's say ACC, ACC equals a string. You know what, I should do this in my environment, since that's what I'm always telling you all to do. And we should get a test. Here I am jumping the gun. Chars is going to be a my list equals a list of H E L L O what? Oh. Space WORLD. We'll just do hello world. Okay, cool. Accumulate my list. So we're returning a string, so let's accumulate on a string. And then we'll say for C, which is short for character. I'm just going to say C, for character in chars. ACC plus equals C. So my accumulator plus equals the character, and then return ACC. Nice, simple, bite-sized accumulator. Oops. Ah, I see. I made a little typo there. Unexpected EOF while parsing. Oh. Missing a parenthesis there. By the way, if you ever see this particular error, unexpected EOF. EOF stands for end of file while parsing. I get this error all the time when I have a test that, or something at the end of my file that I left a parenthesis off. That's almost always what that means. So I see unexpected EOF while parsing, and I hear, you forgot the parenthesis in the last line of your code. So that happens. It's an error you'll become familiar with. What it sees, why it says that is it sees the end of the file, and it's expecting to see an ending parenthesis somewhere. It's like, did you mean to close that off because the file ended? Yeah, so hello world. Nice. Okay, let's submit that. Bingo. Cool. All right. Let's see here if we've got anything else. I'm not seeing any questions. It's about it's 5:30 right now for me in Mountain Time here. So this is the time that I usually will wrap up study hall. So yeah, it's been a good one. It's kind of nice to get back on the horse, as it were, and start doing these again. So yeah, I do appreciate people asking questions. If you have questions, any further questions regarding what we talked about in study hall today, please feel free to DM me. I know I can take a little bit of time to get back to people on Slack, but I will get back to you as soon as I can. So yeah, feel free to DM me, and look forward to seeing you next Wednesday, next time I do study hall. That's it. Bye-bye.